will get is a Word file that looks like the one that we see over here, that is emphasizing that you have to have that exam monitor running once again, and has a bit of information on what it is that you're allowed to do. And here you see what that is. Increase it a little bit more. So you're allowed to use Stata and the Stata help files. And the Stata help files, you may or may not know, that is that's 14 manuals like this wide, in fact, but then as a PDF on your machine. And the way to see that is, let's see, if you, for instance, type help regress, you get the help here. And then here you see that there is an option to also see something else. For instance, this part there, and that will open the manual at the regress part, and there's a big bunch of information, everything you want to know about regression. So that's fine if you use that. What you're not allowed to do is here and there in the manual there are links to the outside world, and also in the help, so to some web page somewhere with extra information. That's not something that you're allowed to do. So as long as you stay within your computer and within Stata and the help files, you're fine. What you're not allowed to do is have preconceived do files with you that you're intending to use with all the commands in it or stuff like that. That's not allowed. And also having a look at the slides during the exam is not allowed. So it's just Stata and the Stata help files, that's it. Of course you need Word, because you need Word to type your answers in. So the idea is that these are the assignments, and you also give the answers in the Word file. A PDF viewer is okay, because if you want to access the help through Stata, then you need that. Something that you can use to copy and paste screenshots, and well, the snipping tool is standard Windows or Paint that might actually do it. If you want to use something else because you're very familiar with that, then please let me know up front so that I can whitelist that program in Exam Monitor, otherwise Exam Monitor will start to complain. And the screenshot is only necessary actually because, well, if you give me an answer, then you need to tell me what it is that you did. And every once in a while, depending on what the actual answer is, it is convenient to, show me the regression table or show me the output of a chi-square command or what have you, so that I know what it is that you did. Don't overdo it. So do not create a large do file with a bucket load of output and then copy paste all that as a sort of addendum to your exam, because I'm not going to go through it. Simply for each and every question, show me what it is that you did. Show me by adding text that you understand what you need to look at and why, and make sure that that helps me trying to understand you. So an answer, if the question is there a difference between this and that, and you type yes, even if that would be the correct answer, I will count that as completely wrong, because it could be just a guess. Maybe you have no clue what it is that you're doing. So you have to do something like, okay, for this I need a command like such and such. This is what the output is, and here in the output I see that there is a difference between A and B. So that's the idea. Okay, if you need a calculator, normally I think you don't, but if you would, then you can use Stata for that. Within Stata, if you type display and then whatever it is that you want to calculate, you get the number back. If you want a dictionary, then this is allowed too. I don't think you really need it, but if you insist, then I'm fine with it. But it has to be a tangible one, not an electronic one. Okay, so no book, no slides, no pre-made notes, no any preconceived somethings, no getting online, getting in contact, or otherwise communicate with others. Okay, all the obvious stuff applies. Then this file is usually called something like this, last name, first name, and you have to rename the file to your own last name and first name and your student ID. That's convenient for me. I do not write explain all your answers for each and every separate question. You have to explain all your answers. In the beginning, for the easier questions, perhaps you can get away with just a number here and there. So I think in a minute the first question will be how many cases are there in the data. Then if you show me the command that you used and then the number, there's no need to write a novel about what that is. But for the questions more at the end, well, it helps if you explain what you do. This is the standard stuff that I have to make sure that's in there. get rid of your phone and these kind of things. There's a password that you need to type that I'll give at the exam. And here are the assignments. So this is something that was using the auto data set from Stata. And in fact, there was another data set that belongs to this exam that will show up in question 3, I think. So all the questions are here, and let's see what we had in the end. Okay, so when you're done, you have to upload this document, and you have to upload that ENC file from Exam Monitor, and that's it. Do note that you're not allowed to upload anything else. So it might be tempting to say, okay, this is my do file, good luck, but I'm not going to look at all these separate do files, simply too much work. Okay, so now what I did here, just for convenience, is put the questions in a do file myself so that I don't have to switch back and forth between the two all the time. So here, this was question 1, and I suggest that we simply go through it. Any questions about what is allowed and what is not at the exam? Or what the material is, you know, all the stuff that we tweet. In principle, what you can expect is assignments of the wiki kind. So all the assignments that you are going to see are more or less the same or similar or slight extensions of what you have done, or at least could have done online. And let's see how that goes. First question is, in that auto data set that we had, you find data about cars, blah, blah, blah. You need not check the data for inconsistencies. The content of the data set speaks for itself. First question is, how many non-empty observations does the variable make have? And just a number is enough. Okay, so let's see. For many of these questions, there are different ways to get an answer. Here, the most immediate command would be count if make is not missing. If you would know how that worked, then it would be fine. There are more tedious ways to do it as well. You can just type edit and then go like this and count. Also works. Less attractive if you have a data set of 2,000 cases or so. Also here, you know, you look there and you see 74, and then you could double check, okay, are all the cases complete? If you find that they are, then you're good to go. So that would be a correct answer too, but you know, the better one would be this one. That will simply run on any kind of data set and would give you the actual number, it's 74. Okay, second question was the median value of the price variable. Again, I suggested don't talk too much about it, just give me the number. The summary command will give you that, and the median value is right there. Okay, so already the first couple of points you earned by doing not so much just yet. Okay, then there are cars in the dataset from several brands, a couple of Audis, some BMWs, blah blah. Execute the following code to create a variable brand. You need not understand in detail what it does, just that it creates a variable with the brand name of the car. So let's see what happens. You execute that part, and let's have a look. A new variable there, that's called brand, AMC, AMC, AMC. So let's see what that was before, an AMC Concorde, an AMC Pacer, and an AMC Spirit apparently. So what I did was I chopped off the first part. Yeah.
Are you allowed to put a print screen in your Word file? So for example, that table that you got from the implement window,
Yes.
are you allowed to put a print screen of that in the Word file?
Yes.
Okay.
Just don't put 54 print screens of all the stuff that you did. So, you know, what I need to know so that I know what you saw and that you understood what you did. But in principle, yeah, that's fine. Okay, so now we have a variable brand, and what did... yeah. Which brand has the highest average price in the data set? So we have different kinds of brands, 3 rows with AMCs and more rows with other brands, and the question is the highest average price. Well, again, different ways to do it. Where are we? There. By brand, summarized price. So now I see, okay, for AMC, the mean price is 4,200. For Audi, it's close to 8,000, and so on. And then still what you need to do is check which one is apparently the highest. Cadillac, close to 14,000. Is that the highest? 13. Yeah, looks like it. So that's one way to do it. Or if you know the table command, then it's slightly more convenient. Table brand, and then as a for the different cells, you want the mean of price. We've seen that before as well. Again, the last thing to do is go through the list and find the one with the highest number. And where is that Cadillac? Right there. Close to 14,000. Was that the highest? Yeah. If you have another way to do this, this is fine as well. There might be different ways that would actually work. There's a command that's called collapse, that if you happen to know it, then that will work as well. So for all these things, you could argue that, let's say, as questions are progressing, it gets more complicated to do it the slow way. Okay, so in the first question, how many cases are there? You could just go, okay, 1, 2, 3, 4, and then arrive at the right answer. This starts to become more complicated as questions are progressing, or actually impossible at some point. Okay, a researcher argues that in any case the variables headroom, trunk, weight, length, turn, and displacement are all measures of the size of a car. It should therefore be possible to create a decent scale based on these variables. Do you agree? If yes, explain why and create the scale score in an appropriate way. Wow, how easy is that? We just did that. Actually, in the slides, the stuff is literally there. What you need to do is this. You need to standardize. All these are measured in different units, and you have to make sure that they're all on the same scale through standardization. The wrong way to approach this would be to forget this part and then conclude the scale score is 126 or so. So not a good scale. In this case, if you standardize, you see that it is a good scale. And rightly so. All these things are measures of the size of a car. Okay, now we're getting closer to other commands. Test whether foreign cars, see, foreign. We have foreign and domestic cars. You want to know how they are coded. You can type NOL for no label, and you'll see that the 1 is for foreign cars, which is actually the way you want it as an indicator variable. So 1 says, yes, this is indeed a foreign car. But in any case, 2 categories here, and have the same price as non-foreign cars. Price is interval scaled. We're comparing an interval scaled variable over 2 categories. You should figure out t-test. Actually, what we want to do is a t-test. So the first thing to do, for instance, would be just run the t-test. Not so much because you already know whether or not this is allowed, but just to see what the different means are, because that will be part of the output. Here you see the domestic cars have a mean of 6,100 and the foreign cars of 6,400. So you'll see already here that there is a difference, at least in the sample. And now we need to figure out if we are allowed to run the t-test here. So let's see what we need for a t-test for each and every one of the groups. We want that the interval scaled variable here, price, is normally distributed. And for that we start with the swilk command. We also have the sk-test command, but we need not bother with that because here we already see that for the swilk command in both groups we see violation of normality. Okay, so t-test is not allowed here. Okay, let's try to get rid of that. Trying to transform price here, and we see that, let's see, this one, that one, well, and also that one, in fact, work, because here we are no longer violating normality, and what we need is that it's the same over there. So let's see, these were the last 3, and the last 3 over there, so the inverse, 1 over the square of price and 1 over the price raised to the power of 3 would all be fine as a potential transformation. Don't know what I did here. See, I actually created all of them. So I generate 1 over price squared, and 1 over price to the 3rd. And let's see, yeah, here I again, the swilk command, but now for all of them. And I chose that swilk command because I know that the output from the ladder command here is based on that skTest command. So there wouldn't be any reason to rerun these normality test commands with skTest because all the output of that is in the ladder output over there. But I'm trying here with swilk, and here we see 1 over price is not working. Normality is violated. Here it would have been okay, but we need both. Then 1 over price squared, this is fine, both above 0.05, so apparently 1 over price squared works. And 1 over price to the third, also not great, because now normality again is violated, in fact in both cases. So it looks like here there's only one that actually works, that's 1 over price squared. Do realize that in this case this is just a coincidence. You might get the feeling, there's exactly one that works, that must be the right answer. But that need not be necessarily so. It could have been that there is no transformation that works. Could have been that all 3 of them worked, and then just choose one, would be fine with me. It's typically not the case that assignments turn out to be exactly fine, because all this is real data, and real data normally doesn't deliver results that are exactly fine. Okay, so 1 over price squared, that worked. And now we compare 1 over price squared. Let's see. And here we see that we do not reject H0, so we do not reject equality. Loosely stated, there is no difference between the two groups. And if you want to be really complete, you could also add that rank sum command instead. And there you also see that equality is not violated. Okay, so foreign cars in the sample are a bit more expensive, but we see no reason to reject equality in the population. Okay, it's good to realize that here the text that you see is only the questions and not the answers. The answers I just typed in here, and then you have to read the output. In your Word file, you have to write not only the command that you use, but also why you conclude that there is or is no difference, because otherwise, I cannot assess very easily if you know what you're doing. Okay, so you need to know. I need to know 2 things: that you know the right command to use, and that you can interpret the output from that command. Yeah.
Is it important to include the entire process of the small ones?
Yes. Yeah. I mean, basically that's for your own benefit. Okay, if you do something stupid halfway, and then take that to, let's say, the correct end, given that you made a mistake already, then it's easier for me to give you some points for that. If you don't do it, and you only give me the result at the end, and I cannot see that you did something stupid halfway, but were consistent for the rest, then there's nothing else that I can do than just say, I don't know, not the right answer, and I don't see any process leading up to it, so it's wrong. Okay, test the relation between the weight of the car and its price. If there is a relation, interpret the size of the effect. That's correlation, because weight is interval, price is interval scaled, and I'm asking for the significance value. And there you have it, a correlation of 0.54, highly significant. And you can say something about the size of the effect. For instance, you can say something about that this as a correlation in general is quite high. It's not really social science data, but if it would have been, this is certainly on the high side. If you would predict weight with price, or the other way around, you would have an R squared of 0.25, 0.5 squared, which is also quite decent. So it doesn't matter very much what you say, but you need to say something about the size of that effect, so that I can see that you know, let's say the kind of correlations that we are supposed to expect in the sort of data sets that we have. Okay, so that was question 1, and that, in principle should be easy. Yeah?
Shouldn't we have checked the data first or not?
No, in this case, yes, Normally yes, but in this case I added a line of text in the beginning. You do not need to check. Here, you need not check the data for inconsistencies. So if that's not there, then you do. But I think pretty much I mention it when you need to do it. But in general, if I don't say anything about it, then be on the safe side and look at your data to see what it is. It is tempting, by the way, because at first I totally stuck to that you have to do that by yourself. But the risk is if you feel that you're, let's say not really up to speed with all the material, and people will talk for an hour about that the data is not right, and they double check for a very, very long time and add 5 pages about the data, and then do not answer the actual questions. So usually I suggest have a look at it, have a decent look, but don't overdo it. Okay, so you have to be able to, let's say, generate enough time for yourself to actually answer the questions that I asked. Then the second one was in this case about sample size. Also something that you need to realize that it might very well be that the number of topics that I have that I could ask about is larger than what I can put in one exam. So in this case, sample size is in the actual exam, sample size might not be in at all, or just a very small part. I think in this exam, analysis of variance is not in there. Simply because there wasn't enough room to put it in, but you shouldn't interpret this as analysis of variance is apparently never in or something like that. I have to make a choice. Okay, next question. A researcher wants to figure out whether in the Netherlands the proportion of restaurants that has the label sustainable differs between two groups, those with a Michelin star and those without. And I added, a Michelin star is a mark of recognition that some restaurants get. Very few of the restaurants get 2 stars, and only a handful in the Netherlands, I don't know, 2 or 3 or so, get 3. The researcher guesses that among the restaurants without a Michelin star, the proportion of sustainable restaurants equals 70%, and that among the restaurants with at least 1 Michelin star, it is 50%. Okay, how large is the total sample size that you would need to test this assertion with a power of 90%? Well, there is a direct command for that. Power 2 proportions, 0.5 versus 0.7, with a power of 0.9. So as long as you know how to do this, then you'll simply get it. And the answer would be 248, 124 in each group. The researcher soon finds out that the maximum sample size that she's able to collect is 35 restaurants in each group, for a total of 70 restaurants. Calculate what this does to the power of the test and argue whether this has implications for the research. Well, all right, same command, 0.5 versus 0.7, and now with an N of 70. You get a power of 0.4, okay? Argue whether this has implications for the research. Yes, don't do it. Power of 0.4 is simply too low, and you can spend your time better with something else. Or nevertheless increase the sample size to something that is halfway decent. But a power of 0.4 means that you have a 40% probability to actually find a difference if it's there. Okay, this is not worth the time and effort. Okay, so that's about sample size. Something that I could have asked here in addition would be if the researcher would have suggested up front that the difference is not 0.5 versus 0.7, but instead 0.7 versus 0.9, would that make the calculation different? In this case, that's easy because you can simply type it and see if that makes a difference. And the answer is, in fact, yes, because the closer you are to 0.5, the larger your sample size needs to be. So 0.5 versus 0.7 is a larger number than 0.7 versus 0.9. And in fact, the biggest difference, the biggest sample size that you would need is if it would be exactly around 0.5. So let's say 0.4 to 0.6. Okay, then there is another data set here called Michelin that has a sample. I have to check if I'm in the right path here. Yes, it is. From a sample of restaurants, the average price of a meal, the number of Michelin stars the place has, whether or not the place is a hotel, and whether the restaurant works sustainable or not, and what kind of restaurant it is. Okay, so here there was a question, check the data for inconsistencies and if necessary deal with them appropriately. So the first thing to do here would simply be to go through all these different variables that you have and have a look. So this is the average price of a, what was it, a 3-course meal. So for 22.5, well, that can't be much. And for 132.5, I do expect a decent meal. But then again, there are a couple there in the data with quite a few stars. Okay, that you do for each and every one of the variables that you see. And let's see, what do we have here? Oh yeah. Yeah, so one way to go about it normally is to look at the extremes. Okay, so if you would have found, let's say, a 2.5 in the data, so that would mean for price, a 3-course meal costs you $2.50. I don't know what that might be, perhaps a dakloze opvang, but that would be weird. And 132, it's imaginable for a very expensive restaurant. If you would have a 350, it would start to be really weird. And that's usually the only place where students look. So what I typically do is to give you the option to get some extra bonus points. If you look at the data here, you'll see that 22.5, 25, 27.5, 32.5. So all these things are rounded to the nearest 250, apparently. And in that sense, it's weird that you find that one in the data as well. 55.66678. So this is a sort of suspicious case, and if you catch it, you get some bonus points for that. Otherwise, I don't think there were really weird things in the data. Okay, then don't be too liberal in throwing away cases. In general, that's not a good idea. So for many of the things for which it's not exactly clear that's a real coding error, just keep them in. Make a mental note or an actual note in your do file so that in the end you can rerun analysis without that case. But don't start with, let's say, throwing out 20% of your data or even 10. Okay, so let's see. Next question was, test whether the proportion of restaurants that has the label sustainable differs between two groups, the restaurants without a Michelin star and the restaurants with at least one Michelin star. Well, now you need to know that Michelin star actually had 3 categories here, 0, 1 and also 2. So first you need to create a variable that says has at least 1 star. I did that here. So I simply first made a new one equal to Michelin star and then changed the ones, or the 2s I should say here, to a 1. And then I get my new variable called at least 1 star. You could do it in different ways with a recode or what have you. So the point is not that you do it exactly in the same way as I do it, but just that you do it right. Let's see, what was the question again? The proportion of restaurants that live sustainable. Yeah, okay. So I'm running a cross tab here. Place is sustainable, no, yes. At least 1 star, no, yes. Chi-squared, what I need to check here is that the cell counts are high enough, where the rule of thumb is should be at least 5. Well, lowest one is 8, so this is fine. And we get all the, because I typed all here and exact, we get all the tests anyhow. So what do we see? Well, all values here above 0.05, so apparently no difference. Okay, if you happen to know that there is also a PR test, so proportion test command, we didn't really treat that in class, but if you would have found this in the book, this would be fine as well. But this would be good enough. Okay, now we do get some analysis of variance actually. Presuppose that the underlying assumptions are met, so don't bother too much with that up front, and test whether the average price is equal across the kinds of restaurants. Okay, the first thing to realize would be in all likelihood that will be rejected. You know, there are so many different kinds of restaurants that it's not very likely that they all have the same price. And as you may know, either from experience or from just looking around, a standard pizzeria will have lower prices than your average French restaurant in all likelihood. And between which restaurants is there a significant difference in price? Okay. So first let's have a look. This is the general analysis of variance command. Price as the thing to predict with what kind of restaurant it is. And we see here totally significant. Yes, there is a difference between the different kinds of restaurants. We do not know just yet between which ones, but there is at least a difference. And to figure out which ones, well, okay, the first thing to do would be perhaps to look at the means to get already a bit of an idea. So perhaps just for a second here. 0 is another kind, French, international, pizzeria, Chinese, Japanese, or Mediterranean. And we see here, well, the reference category other is left out. That's category 0. Which one is the highest? 35, I think that was Japanese. So apparently Japanese restaurants are the most expensive. And the cheapest ones are 3 and 4, because here you see the lowest coefficients, pizzerias and Chinese restaurants. Okay, so that already gives you a bit of a feeling for where the differences are, and we can actually test this with the one-way command. And because we have quite a few comparisons to make here, we have 7 different categories, and all these differences have to be tested. We want that Bonferroni correction included. There you have it. All right, so now let's see, where do we find significant differences? We're looking at values here below 0.05. No, 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 yes. So there's a difference between 0 and 5, between 1 and 2, between 1 and 5, between 2 and 5, between 2 and 6, between 3 and 5, and between 4 and 5, and 5 and 6. So, okay, the easier thing to do here would be you either make a screenshot of this table and you add some circles around the ones that you see are significant, so that I can also see that you know where to look. And then you conclude, okay, the differences are there where these significant values are. Okay, I hope you note that, you know, all these kind of things, we've done this. So this should be, if you know what you're doing, you could be home in an hour. Okay, so apparently that usually doesn't work that way because many people stay longer than that, but it shouldn't be that difficult. Okay, now testing the assumptions. Yeah, now it starts to become tedious. Okay, what do we need for analysis of variance? We have 7 different groups, 0 to 6, and we need normality for the dependent variable in all groups. Okay, so let's do it. We type that swilk command here, and we see already here in the input where I added the answers that normality is rejected in these 2 cases. And here again, oh sorry, no, I was looking in the wrong place. So here we already see I'm trying the swilk command, it's not working, so there's no need to run that SK test command as well, because we see already here that it's not okay. I'm trying standard transformations. For one category, this is not working because we have only 3 observations in there. Okay, now you can say one of 2 things. First of all, transformations don't work because for that 3rd group, it's not going to work at all because the group is too small. You know, that's one way to go about it. The other thing to try to consider would be, well, let's try to figure out if there is at least a transformation that works for all the groups except 3. Wouldn't be so bad, but apparently that's not working. See if we can see that in the output. Well, let's just look. There we have the letter command. Okay, so we're looking for something that works for each and every category. Obviously, the more categories you have, the less likely it is that you'll be able to find one that actually fits the bill. And if you check, then you'll see that here, it won't be possible to find one, because for that second group where normality already was rejected, there is not a single transformation that will actually help you out. So there is nothing that works for each and every one of the categories. Same, almost the same here. Here only 2 or 3 might work, and if you double check, yeah, these are not there. So there is no good transformation that'll work. For that you have another command, Qualys for Kruskal Wallis. Again, realize that we checked before and we actually think that we should find a difference here. And we do. Totally significant. One way to look at that is if there wouldn't be a difference, these rank sum numbers would be about equal. And they are certainly not equal here. Very low and very high values. Okay, predict the price of an average meal from the other variables in the data. Include variables appropriately. Do not check assumptions just yet, but at this point just assume that they are met and interpret your findings. Okay, a couple things you can do wrong here. The main thing you can do wrong is either you're forgetting variables or you're putting in variables in the wrong way. So one thing to have here is that i.restaurant kind, that you need. Restaurant kind is categorical, so that there's no way you could include that as an interval scaled variable. I mean, you can, and still it will give you results, but it would be nonsensical. For Michelin star, you can debate about, do you expect a linear effect from 0 to 1 to 2 stars, or do you simply want to create separate dummies for 0, for 1, for 2? Might work as well. Here I made separate dummies for them. And here I ran this once with and once without the beta command. The beta command will allow me to say something about which variable here is the most important, has the strongest effect. So here we have our output, and let's see. Okay, so Michelin star, we see that there is a coefficient of 10 here, so we're predicting price. So on average, the Michelin star restaurants that have 1 star are about 11 euros more expensive, and that's significant. And here we see, which is, it's a bit odd if you see this at first. Indeed, there is a higher difference there, 19 extra euros for 2-star restaurants on average, but not significant. Here you actually see that it's easier to find significant values if you have a larger sample. The sole reason that this thing here is not significant is not that this value is not higher, because it is, but we have only 3 cases in our data that are supposed to take the role of the 2-star restaurants, and that's not enough apparently. So here I would feel totally comfortable saying that, yeah, there is a real difference there. If we would have had way more restaurants in our sample, then this would be fine as well in all likelihood. But in any case, you see 0 versus 10 versus 19. That's the difference between the restaurants. Hotels, in fact, are more expensive. So if you have a restaurant in a hotel, that's usually more expensive. Sustainable restaurants, there is a slight effect here. They're a little bit cheaper, 4 euros for a 3-course meal. Well, it doesn't matter so much. And it is on the borderline of being significant. And still these differences between different restaurant kinds. And then if you want to have a look at the beta commands, you will see that typically there, you see the highest beta coefficient for the ones that are not included over here in the restaurant kind. So you see that being a hotel, in fact, has the major impact. And the other thing that has a major impact is over there. And that's number 5 again. So if you have a Japanese restaurant, it's also way more expensive. So these are the 2 things that have the highest impact in the data. Okay. Then what? Come up with an argument. No need to do the actual analysis for an interaction effect between 2 of the variables you used under question E. Yeah, there you can come up with lots and lots of different arguments as long as they are really about an interaction between 2 variables. So basically what I'm asking here is show me that you understand what an interaction effect is. And in principle, however weird the argument you can come up with doesn't matter so much, as long as it is saying, okay, the effect of one predictor variable depends on the value of another predictor variable. for some or another reason. So, you know, you might think that, let's see, what could we have here? For instance, you see a small effect, a small negative effect of being sustainable, which is perhaps a bit weird. So you could think, well, indeed, there might be an effect of a restaurant being sustainable, but that effect is way bigger in hotels than it is in non-hotels. Because if you're in a hotel, then you have a sort of a high-class restaurant. If then you need to get sustainable stuff, it's way more expensive. So it is likely that the effect of being sustainable is different in a hotel than outside. Okay, I'm not sure if I really believe the argument, but at least it would be consistent with expecting an interaction there. Okay, then the next question is, all right, so you came up with an interaction, now test it. So in this case, apparently I made an argument here about that the effect of a Michelin star is different for hotels than for non-hotels. So I include this one, and I rerun the whole thing. Let's see. There we have our interaction, and no, not significant. So that argument that I came up with apparently doesn't work. I thought here that the effect of an extra star is different for hotels than it is for non-hotels, but it's not. Okay, then H, usually one of the later questions. This was a regression. Regression has assumptions as well. Make sure to test all the regression assumptions that you would need here. And then, yeah, I don't want to go into the details of all of the separate ones here, but the thing to do would simply be, go through the list as you had it in the slides. So we know that we need normality of the residuals, we need homoscedasticity, we need linearity, what have you, we need independence, and still a couple of others. I didn't put all these in the do file here, but you simply go through them one by one. If you find a problem, you can try to solve it, depending on what it is. So if, for instance, your residuals are not normally distributed, that's not so bad. You can use robust standard errors, and we would be good to go. Same thing for if you find heteroscedasticity, then you can also use robust standard errors and would be just fine. In fact, here, I'm testing for homoscedasticity, and here I'm running the same command twice, once in its standard form and once with robust standard errors. And the typical thing to do would be, all right, now apparently something was wrong that I had hoped to repair with robust standard errors. Are my conclusions any different than I would have had before I checked the assumptions? So let's see, this one was a standard one. 10, 19, and significant no. Okay, 10 and 19, significant no. These values are slightly different, but the conclusions do not change. Hotel is highly significant, sustainable is not. Hotel, highly significant, sustainable is not. Oh, well. Oh, is. So there is a slight change there. This one was statistically significant. If I use robust standard errors, not anymore. Okay, so normally I'd like to, let's say, stay on the safe side in two ways. First of all, if I have some evidence, as I do here, that there is no significant effect of sustainability, I'm tempted to go with that. Because if I say that there is, this is a stronger statement in a way. Also, I know that the right thing to do here would be to use these robust standard errors because normality is violated and homoscedasticity is also violated. So in that sense, this is the better one. So here I concluded, perhaps there might be an effect, even though it's quite small. And here I'm tempted to say, well, on second thought, I don't think there really is an effect of sustainability. Okay, you can double check the differences here. You see that most of these are actually significant in this case. And there is also a slight difference there. So there are differences between restaurants that also have changed compared to the original implementation. All right, so, and there are, by the way, different ways to cover this. Besides just trying robust, another thing would be try transformations of the variables that you have here. In this case, there aren't so many that you can try because there aren't that many interval scale variables that you could try here. Hotel is 0, 1, sustainable is 0, 1. If you have at least one Michelin star, that's also 0, 1. There's no need to transform any of that. And the categorical variables, in any case, you cannot transform. So the transformations in this case didn't make much sense. But if you would have had, let's say, 5 predictor variables where each and every one of them would have been interval scaled, you could have tried transformations for each and every one of those, hoping that you get a model that fits better. Okay, yeah, then of course on the dependent variable side you could also think about whether or not there are ways to improve there. Well, price necessarily is positive. So we know that we want to create a model that has only positive predicted values, and the way to do that would be to include the log of price instead of price itself. And here I did this as an example. Again, what you would typically do here is look at the original one that you had, compare it with the new one that you now get, and try to figure out if there's anything in particular in terms of which variable is working that makes a difference. Now you, by the way, see that sustainable is totally not significant. So again, some proof that apparently that sustainability effect is not really there. These are still the same. This one is significant, this is not. This one is highly significant, also still the same. And typically what you want to find here is, well, one of two things. Either none of your conclusions change, which is great, then apparently it doesn't matter so much if you choose one or the other option. Or you see that, if I take log price instead of price, or if I take robust standard errors instead of non-robust standard errors, there is a difference, and then you have to think hard about which of the two options is actually the best one to use. And that's pretty much it. And usually, I must admit, I keep the assignment with the most work, so in this case the testing of assumptions somewhere towards the end, and the ones that you can answer, let's say, relatively quickly, or at least with a relatively restricted set of commands, more to the front. And on the other hand, you do get more points in general for questions for which you need a longer answer. So you can take the number of points that you get per question as a clear indication of how long your answer is supposed to be. Okay, so if there is all questions are 2, 3, 4 points, and then there's one in there that has 12 points, and you have a 2-line answer, that's not very likely to be correct. That's it. Any questions about? Yes.
In one of the wikis, you had the rank, and one of the comments was, don't always use back. I was wondering why it's wrong to always use back when you do regression.
Yeah, well, wrong. In the wikis, there was someone, perhaps you, no, it wasn't you, who had run all the regressions there standard with that beta option there, and also just with the beta option, so not without. In principle, the results are the same. It's the same model, but you want the separate results. Normally, because the regression without the beta command, it's way easier to see what the effect of the coefficient is. So where we have a regression there. So I typically like to look at the standard regression and then look at the coefficients here to try to figure out, okay, I understand what this means. This is simply meaning an 11 euro difference between the 0 group and the 1 group, and the 19 euro difference here. I can also immediately look here at these values over there. And in principle, you can see all of that also from the beta command. But that beta command, it sort of forces you to look at that final column over here with only the betas. So I think in general it's good practice to stick to the original one with no options, standard regression analysis. If you insist on using that beta all the time, the only thing that I wanted to make sure in the wiki is that it's not, let's say, a general rule that you have to type beta all the time. But in principle, all of that can be deduced from the same kind of table.